Okay, this week we're talking about right triangle trigonometry. And before you freak out, we actually don't need to know very much trig to do energy management. We were we need it for a few things, like talking about power factor, um, electrical stuff. We'll talk about that later in the term. But for now, let's just talk about the theory of right triangle trig. So of course a right triangle is simply a triangle that has at least one, or I'm sorry, that has exactly one right angle. And we usually denote that with a little square in the corner. So if you see that little square, it means that angle is 90 degrees. A lot of times you'll see these angles denoted with letters, so ABC. And sometimes the sides are denoted with lowercase letters. And usually the side opposite the angle is the lowercase corresponding of that letter. So lowercase a would go here, lowercase b would go here, and lowercase c would go there. So if we have a right triangle, some things we know already. We know that for any triangle, the sum of the angles is equal to 180 degrees. And if C is our right angle, we know that A plus B must sum to equal 90 degrees. So for example, if A is 30 degrees, we know that B is 60 degrees because C is a right angle. We also know the Pythagorean theorem, which says A squared plus B squared equals C squared. And of course here we're talking about the lengths of the sides. So A squared plus B squared equals C squared, Pythagorean theorem. So what right triangle trig allows us to do is go beyond these basic rules and determine even more information about right triangles. And we do that using trig functions. And there are actually many trig functions, but the only three that we care about are sine, cosine, and tangent. And those are often abbreviated with the first three letters, so sin, cos, tan. Okay, so here I've drawn that same triangle from before. Angles are capital letters and sides are lowercase letters. So if we just look at this triangle for a moment, we can define the trig functions of angles A and B like so. So if I have sine of angle A, it's equal to the ratio of little a over little c. So we take the length of side A divided by the length of side C. That's equal to sine of angle A. And these functions, these trig functions, are just, they work the same as other functions. So functions like x squared. If you take x squared, if you take 4 squared, you get 16. So it's just some operation on the value you put in here. And this is a way to calculate it. So if you put sine of 30 degrees, for example, into your calculator, you get 1/2, which means that you know that side C is exactly twice as long as side A if A is equal to 30 degrees, if the angle A is equal to 30 degrees. So based on that, if you have a 30-degree angle and you've measured side A and determined that it was 5 units long, then side C must be 10 units long. Okay, so we have cosine of A is B over C. And finally, tangent of A is A over B. You can also write these functions, sine, cosine, and tangent, in terms of angle B, but the formulas will change. You can check the notes for those versions, but perhaps an easier way to remember is to think about angle theta. So theta is just a Greek letter, theta. So choose either of the acute angles and call it angle theta, and then you can define all the functions in terms of the sides if you label the sides properly. So the hypotenuse is always the longest side. You label that one first. Then you look at angle theta and look at the opposite side, and you call that opposite, so OPP for opposite. And then the only other side is a side that we call adjacent to angle theta. Just don't confuse it with the hypotenuse. The hypotenuse is also adjacent to theta, but it's a special side because it's the longest. So the other adjacent side is what we call adjacent. So once you have those three sides labeled and you have chosen one of the angles to be theta, you can write the trig functions like this. Sine theta is equal to opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. And tangent of theta is opposite over adjacent. Now if you compare these formulas with the formulas here and note that angle A is equal to angle theta in this case, you'll notice that all these formulas correspond. Similarly over here, if you've chosen this top angle to be theta, the hypotenuse label stays the same, but now the opposite side is the one down here because that's the side opposite theta. The adjacent side is over here because that's the one that's adjacent to theta. The formulas stay exactly the same, it's just that which side is which has changed. So some people find this notation easier to remember than the A, B's, and C's. Personally, I prefer this because you can use a mnemonic device to remember it. And that is SOHCAHTOA. So here you have sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So if you just remember SOHCAHTOA, and you know where the adjacent side goes and the opposite side goes based on what you've chosen for angle theta, then you know all these formulas if you just remember this mnemonic. So the way we use these formulas in practice is to start with a triangle where we know some information and then find the remaining variables. So again, we only deal with right triangles. So let's say that I give you this angle up here is 60 degrees, and let's say this side is 5. We're going to find the other information in the triangle. So we need to know side A, side B, and angle A. Those are our unknowns. We know 60 degrees is this angle. We know this angle is 90 degrees. And we know the side is 5. So angle A we can immediately see right away because if this is a right triangle, the other two angles have to add up to 90. So if this angle is 60, this angle is 30 degrees. So we know that angle A is 30 degrees. Okay, so now we need to use trig to solve the rest of it. So I have the hypotenuse is equal to 5. So we ask ourselves, is there something we can do, or some trig function of A that involves the hypotenuse? And we have two to choose from. Both sine and cosine involve the hypotenuse. So we can write a formula. Sine of 30 degrees. Remember, if this is my angle theta, that's 30 degrees. It's the sine of it is equal to opposite over hypotenuse. So side A over 5 in this case. And our goal now is to solve for A. So if I multiply both sides by 5, I get 5 times the sine of 30 degrees equals A. And if I simplify this, sine of 30 degrees on the calculator gives us 1/2. So 5 times 1/2 equals A. So A equals 2.5. So I'll put that up here. Side A equals 2.5. Now to solve side B, there are several options. We could use the cosine of 30 degrees to do that. So cosine 30 degrees equals B over 5. Because cosine is adjacent and side B is adjacent to angle A. So 5 times the cosine 30 degrees equals B. If you do cosine 30 on your calculator, you'll get 0.866, which is actually square root of 3 over 2. And if we multiply that by 5, we get B. So 5 times square root of 3 over 2, that gives us 4.33. So side B is equal to 4.33. Now we could have also solved side B by using the Pythagorean theorem. So let's do that and make sure that our answer was correct. So we have a squared plus b squared equals c squared. We know that a is 2.5. We know that b was 4.33. And we know that c is 5. So we want to make sure that this equation is true. And if you do this on your calculator, you'll see that it does turn out to be true. So we've solved this problem. So A is 2.5, B is 4.33, and the unknown angle A was 30 degrees. So now we know everything there is to know about this triangle. Okay, let's do a slightly more complicated example. Here I've given you just the lengths of the sides. So we have 3, 4, and 5. This is a famous type of right triangle, 3, 4, 5 triangle. And it's famous because it's one of the few right triangles that has, integral lengths of sides. There's no decimal places. So our task is to find angle A and angle B. We already know this angle, of course, is the right angle. So now we need to find angle A. We have to use trig to solve this. So we have 3 options to find angle A. If we do the sine, it's equal to the side opposite of angle A, which is 3, over the hypotenuse, which is 5. If we do cosine of A, we do the adjacent to A, which is 4, over the hypotenuse. And then we could do the tangent of A, which is opposite over adjacent, or 3 over 4. So you'll notice that all 3 of these options, A is the unknown variable, and it's written in terms of these trig functions. So the question is, how do we solve for A when we're taking a trigonometric function? The answer is we have to use the inverse functions. So, for example, if I take the inverse sine of both sides, I get A equals inverse sine of 3/5. So inverse sine means do the opposite of sine. So we typically write it with a little -1 exponent here. It's not a reciprocal. It doesn't mean the same thing. It means the inverse sine. Or another way to write it is A equals arc sine of 3/5. That's often abbreviated ASIN, 3/5. So on your calculator, it could appear, any of these could appear as a button. Most calculators use this type of notation to do inverse sine, but you should be familiar with these other types. So let's do that on your calculator. Let's take the inverse sine of 0.6. If you do that, you will get something like A is equal to 36.9 degrees. And if you want to check your work, just type in 36.9 in your calculator and hit the sine key, and you should get 0.6 back. So now for b, we could simply subtract 36.9 from 90 degrees, because a and b have to sum to 90. So 36.9. So b is approximately equal to 53.1 degrees. So b is 53.1. A is equal to 36.9. And we're done with the problem. But let's do another example. Let's say we ended up calculating b first. We'd have to use trig to do that again. So I could do sine of b is 4 over 5, because remember, opposite and adjacent switch if we change angles. So the side opposite of b is 4 and the hypotenuse is 5. We could do cosine of b is 3/5, or we could do tangent of b is 4/3. So this time let's use cosine. Cosine of b is 3/5, therefore b is equal to inverse cosine of 3/5. So on your calculator, take the inverse cosine of 3/5, and you'll get approximately 53.1 degrees. So if you can do the example on this slide and the example on the previous slide, you can solve any right triangle given enough information. So you've got to be able to work with these, these trig functions both in the forward direction and in the backward direction. So be able to take the sine of an angle or take the inverse sine of a ratio to get the angle. Same goes for cosine, same goes for tangent. Now one thing you want to avoid is confusing these functions with other buttons you may see on your calculator. You might see a button that says sine with an H next to it. This stands for hyperbolic sine, and the hyperbolic trig functions are not functions that we use at all. So don't use those. Just use regular sine and inverse sine.